plus 1. I told him to get out, and then I said, better yet, don't you play baseball? I think Coach Beck probably has a spare seat for you in his room, and so we walked to Coach Beck's room together. Of course I do. I will handle it. An ad? For what? Okay. Y equals x squared plus 1, y equals x plus 3. I'm revolving this about the x-axis. So let me draw a picture. You always have to draw a picture. If you don't draw a picture, you're going to be lost. Did you do a good job?
Well, no. He was like, that's just money. I was like, yeah.
All right. There's x plus 3. It's got a y-intercept of 3, and it's got a slope of 1. Okay? So here's the, you really have to picture this shape that's being revolved, okay? So, radius of the whole thing, the big radius, the whole, right? The whole radius is x plus 3. The empty space radius so the area, the last one I did what? I will when I do area. I will when I do area. You with me? I'm telling you, if you draw a picture, it makes it so much easier. All right, so the area of the wall, can you see over Wyatt? The area of the wall, or the entire thing, is, because it's a hole in a hole. All right, y'all do that so much that I didn't realize whenever it really was jelly the last time. Okay, well, y'all used to it. Area of the entire thing, pi times r squared, so I just square this x plus 3. Area of the h whole, x squared plus 1 h whole. This would not, because this would be pi times x squared plus 6x plus 9. This would be pi times x to the 4th, Hush Logan, plus 2x squared. Yeah. So this one I'm not look. Whenever you find the area, like if I simply asked you what's the area of the shaded region, you would do the integral from this point to this point, which we're gonna have to find anyway, and that's whenever I would do top minus bottom, and that gives me the area of the shaded region. But for this one, I have to find the areas first, and then subtract them. Each cross section, each thing you pull out looks like this, right? So what I have to do is I find if this is the big radius, this is the little radius. To find this area, it wouldn't work if I just subtracted the radii and then plugged it into the area formula. I would have to find the area of the entire circle and then subtract out the area of the little middle. That's great.
Green.
Okay. If it says revolve, always do area minus area. That's the easiest way I know to tell you to remember. Okay. All right, so I'm going to do, the volume is, I'm going to integrate, but again, look, I've got to find what are these points? What are those points of intersection? So where does x squared plus 1 equal x plus 3? No. X squared minus x minus 2, which would be x minus 2, x plus 1. So I'm running from -1 to +2. Yes, way. All right, and then I do which one minus which one, Noah? What you think? Whole minus whole or whole minus whole? Whole minus whole. So I put the pi on the outside, and I do x squared plus 6x plus 9 minus x to the 4th plus x squared plus 1 dx. And this is a polynomial, so it looks a lot worse than this. It's just a little bit involved. I'm going to clean it up first. Negative x to the 4th. Let's cancel. No, that leaves me with minus x squared plus 6x. Is this what y'all got?
I didn't get it because I accidentally added it.
Did I do it wrong?
No, you did it right. I did x plus 3 minus x squared plus 1 plus 1. That's what I have to add over
Plug in a tube. These are those problems where one problem takes you a whole page. Yeah. Did you not? I always work it out by hand usually if I can. More challenging that way. Yeah. 2, 4, 8, 16, 32. 32 to negative 32 over 5.
What, Logan?
Well, but you know, AP exam, if you didn't have a calculator, if this was a non-calculator problem and you're on the AP exam, even if it's calculator, you could literally stop right here. And they would, if it's right, they'd have to give you, if you can plug it into a regular calculator and get an answer, you can leave it there. All right. Not like a big fancy graphing calculator, like a regular scientific like calculator. All right, I don't know. What does this come out to be? To save time.
50. I got 5. Oh, wait. 170.
If you did put it in your calculator, you could go math, enter, and get that fraction too. Anna, which one were we talking about yesterday? 19. I know y'all need 19. Why aren't y'all writing?
Because I'm getting it. I got it.
Thank you. For setting the example for Logan to follow. Number 19. This one was definitely by hand, but it was a fairly easy one by hand. Y'all. Oh, thank you. All right. First thing, if you see secant or cosecant, these are just graphed. You have asymptotes, and then in between each asymptote, it's kind of doing this. One of them, secant in fact, crosses like this, and this is one. The other one is just shifted over, okay? Who?
Garrett, nobody's doing anything.
Who's bothering
They're
you?
not talking to you.
Logan and Noah bothering you?
Yeah.
Are they making fun of you?
Noah and me have not said anything.
Logan.
Logan?
I would never.
I wouldn't even say they were doing anything.
I'm a good friend.
It's on my
and-
side. They just said it.
Don't follow your mom. Ignore him.
I said,
There's y equals square root of 2.
okay.
No, it's not. It's way.
Oh, that?
There's a lot goes to that. After like that day, it was like 0.2 away from one.
Anna, did I do square root of 2 equals secant x to find where those values happened? I just ran it from negative pi over 4 to pi over 4, didn't I? Well, so it says that that's your range of numbers for your x values, but okay. Technically, I should have said square root of 2 equals secant x, so where do these intersect? Because what if they had intersected down here and it wasn't quite at pi over 4? You see what I'm saying? It should be intersecting at pi over 2. If you do square root of 2 equals secant x is what? 1 over cosine. So if I flip both of these, I get I get 1 over square root of 2 equals cosine x, which if I rationalize that denominator as square root of 2 over 2, where does that happen? Where is cosine square root of 2 over 2? Pi over 4. That's where they both are. So it does happen to be pi over 4, but theoretically you would want to set those equal so you can make sure those were the intersections. Okay, but here we go. Noah, you ready? Radius of the wool. What is it? This is not the gap, this is the whole thing. Dozier? Put that up. Square root of 2. The whole is square root of 2. What is the whole? Secant x. Right. Okay, but wait, that's not the area. So the area of the whole is pi r squared, which is pi. The area of the whole is pi secant squared. Everybody good? Yes, thank you. That's why. The volume, I'm going to do pi, and I'm going to integrate from, because this did intersect here, this is pi, negative pi over 4 and pi over 4, to pi over 4 of the whole minus the whole. No, I like it. Okay. Pi times 2x. Oh, Wyatt, how did you know to put 10? What rule? It's the antiderivative of secant squared. Because if you take the derivative of tangent, you get secant squared. I should finish this problem. All right, so I get 2 times pi over 4 minus tan pi over 4. Isn't this fun? Minus 2 negative pi over 4 minus tan negative pi over 4. I'm going too fast for y'all. This is a half a pi. Yeah, it is. Minus tangent of pi over 4 is what? 1. Minus, this is a negative half a pi. What? Minus, what's the tangent of negative pi over 4? Negative 1. She's not sad. You're welcome. Wait, this was this, so now it's going to be minus. Very confusing there with the signs. Okay, pi times, I got 2 pi over 2's, which makes a pi. 2 halves of a pi make a whole pi, yes? Minus, and I got 2 negative 1's. Yep. You did this whole thing right all the way down, and then you get to that very last step and say pi squared plus 4. Yay day, yes, we'll get there eventually, yeah. The square root of I think that's what Ellen was saying she was doing on the other. You did top minus bottom.
Yeah.
Some of them might be depending on the graph, the way the graph is. Yeah. Why what? I don't know. Why would I know that?
It's a common trivia question.
What's the answer?
I don't know, I was asking too.
Thought there was like an actual reason.
How do you know when to do what?
Yeah, I need that.
If I wanted I'm not a fan.
All right. Time. Where's yours? No, ABC.
No, we're out of new lessons. We're rotating the other way right now.
Exactly.
Revolving around the y-axis. Or revolving with respect to y.
Hey, can you undo my guardrail?
Whoa.
Swiggy, can you undo my guardrail?
No.
Please? Please do it.
What's this lesson called? Revolving with respect to y. I thought you were telling me no, this on this call. I was like, oh, you know why I think it's so crazy?
Have we already done
The
this?
rain. No. All right, look.
Like that. Yeah.
Okay. What does that entail? We're rotating the other way. So with respect to Y, right, Logan? Right. Logan!
And then preparation.
What in the world?
Hamlet.
I better know this before I write essays on it.
All right.
Rotating around. Wait to it, where, how would it rotate?
Like, is
That might work.
All right. I am rotating this shape around the line x equals 2, not the x-axis. Around the line x equals 2. So I have a solid. I'm gonna do it first about the line x equals 2, then I'm gonna do it about the x-axis. And I want you to be able to see the difference in the shapes here as we do this, okay? So about the line x equals 2, do I have a solid or do I have a hole? If I go about x equals 2, a solid. If I'm rotating around this line right here, it's sitting flush, there's no hole. It is. That's exactly what it's going to look like. And it's got, but no hole in the middle. No hole in the middle. All right. So.
Everything's a circle.
Everything's a circle when you revolve. You circle around a fixed point, you're going to make a circle. Okay. We're going to find the area of a circular section. And we're going to, all right. So I need a radius. What is my radius if I'm rotating around? Remember, I don't have a hole, right? Not a hole. So what is my radius? This time, notice I'm going this way, right? Instead of the other way. Okay, x squared is the height. What is this if you solve it for x? Yes, say it again. Square root of y. That whole, no, not the whole white line, but just to here, right? From the y-axis to the curve is the square root of y. Do we agree? Okay, so if you solve it for y, it gives you the height, but if you solve it for x, it gives you the distance over. Because x is the distance over, right? All right. Yes. Okay, so that's still not the shaded region, right? That's not the radius. That's not what I need. This one doesn't have, this one's a solid. But in order to find the radius of the solid, I have to kind of think of holes. Because whenever I measure, I'm always measuring from the axis itself. So from here to here I can measure, and then I can also measure from here all the way over to here. I'm doing right minus left, right? So the radius of my shaded region is going to be 2 minus, not y squared, square root y. Yes? So the area of one cross section is going to be, put it up, Dozier, pi times 2 minus square root of y squared. Yes? And now I've got to integrate, but remember I'm doing this with respect to y, so I can't go from 0 to 2. So what? Where do they, where does, if I put a 2 in here, y would be, this point where they intersect is 2, 4, and I'm using the y. So I'm integrating, because where do they intersect? Where does the line x equals 2 intersect with y equals x squared? So put the x in there for 2. So now the volume of this, I'm plugging it in. I'm going from what to what? 0 to 4, 2 minus square root of y squared dy. It's definitely not 0. This point of intersection, I'm going from here up to here. That point is 2, 4, so I use the y part. Yes. No, this will be a non-calculator.
Can't do that.
What? Oops, that's a line. I just foiled it. If you need to foil it off to the side, foil it off to the side. I still antiderivative. 4y minus, this is a half, add 1 to it, I get 3 over 2, and flip 2/3. Yes. All right, let me go back. 3 over 2, so 2 over 3, so 8 over 3. 4 times 3 over 2, nope, 2 over 3. Add 1 to this to get 3 over 2. Multiply the number in front by the reciprocal. There you go. Who said they only wanted to do ones with a 0 bound on them? There you go, Noah. This one's for you. 4 times 4 minus 8/3. No, it's not. The difference in what and what? We're rotating it the other way. It doesn't change the process or the method or anything now. I told y'all that was the last concept. We're just digging into it. Is he taking notes or drawing pictures? Hieroglyphs, okay. Okay, the square root of 4 is 2, and 2 cubed is 8, and 8 times 8/3 is 64 over 3. The square root of 4 is 2, and 2 to the third is 8. So 4 to the 3 over 2 is 8, and then 8 times 8/3. 16 times a half. Chances of you having to do this by hand are slim to none. If it's an FRQ, you could leave it there. If it's a multiple choice, then You'd have to take it a little further, but yeah. Gross, what's 16 times 3? 48? This is 48 over 3. I like this kind of stuff though. This is 24 over 3. So 48 and 24 would be 70. 70 minus 64 would be 6. Shut up. We did all this and got 2.
I thought it's 72 minus 60. It's 8 over 3.
What's 16 times 3?
48 plus 24.
Oh, dang it.
Stop at the
All that work just to get that far.
Thank you, Lord. Thank you.
What's 72 minus 64? Let's see what they got. Y'all. Oh, never mind. I don't see an answer for this one. While I do that, rotate this about the y-axis. Same song and dance, rotated about the y-axis. Now you got walls and holes. Walls and holes.
Why did you walk up on me for the No, I'm gonna make it Ain't No Other Man by Christina.
Stop being proud of these things, Wyatt. You're embarrassing.
Everybody congratulations that kids in dance.
Come get your mom.
I sent you a video of it. I heard it. I thought, what's something on my bucket list?
I was reading my mind and I was plug in. What's that little light in there? Y'all think that's enough. The hole is like everything here. So they get it like and produce it. You need it. How are you gonna? How's it gonna be useful if you can't produce it when you need it? All right. Miss McGee, I need
Hey, this McGee, this one's hurt. Let me have my music. I did so good.
You have it.
No, I did. I'm not listening to anything.
Nobody around you can focus, Logan. Okay. Are you cold? All right. I know. I'm thinking. Say it again. Yes. This is my hole. This is my hole. Okay, this time I have a hole, so I have to take that into account. So this time I have the radius of the wool, which is 2. Because it's if it ever rotates this way, you have to do it with respect to y. If it ever rotates this way, that's a good question though. Did y'all hear that? If it ever rotates this way, you have to do it with respect to y. If it ever rotates this way, you have to do it with respect to x. Let me ask you something though. I was just fixing to say, do you think you'll get the same thing or no? What did your shape look like when you rotated it around the line? It was solid. This one has a hole in it, but does it have the same amount of volume?
Yeah.
Do you? Let's work it and see.
Wait, you know the setup. Once you know the setup, we know it's the exact way.
Amount of solid is not.
Because that's just going to be square root of y again. We're going to do 2 minus square root of y.
No, it's 2 minus
So, we don't have to do that. It's the same thing.
I respect that.
This is the distance to the graph. And then we do the whole, remember we don't do any subtracting when we do holes and wholes. We only have to do that whenever we're about a line. Right, and that's where we subtracted. We did right minus left. So is it gonna be? That's the question. Well, let's do it and see, because I said so. Say it one more time. It's not. It's not. That's what I'm trying to. It's right. Right. If you're rolling this way. No, you're not. Don't say that. If you're rolling like this, you're X. If you're rolling like this, you're Y. Okay. Area. So I'm integrating. I'm still going from 0 to 4. What? I unblocked it for the whole class. I clicked unblock for whole class update scene.
What number is this? Yeah. Oh, this one? Yeah, it's coming from the area of the wool. And you'll think of me, Hannah. No, I'm just kidding. You think?
I think they both.
So you got 4y minus 1/2 y squared times pi evaluated from 0 to 4.